In this video for section 3.3, we're going to talk about something called the empirical rule. The empirical rule is used for what are called bell-shaped distributions. A bell-shaped distribution is something that looks like a bell. So it has a peak in the middle, it's symmetric, and then it tails off on both sides. And we're going to talk more about these distributions later in the course. But for the empirical rule, what it says is that about 68% of the values in a data set will fall within one standard deviation of the mean. So this dotted line here represents the mean plus the standard deviation. The mean is this red line in the middle. The mean minus the standard deviation gives us this dotted line. And between those two dotted lines, we would expect to have about 68% of the values in the data set. This dotted line is calculated by finding the mean plus 2 times the standard deviation. Or I could take my previous dotted line and add the standard deviation to that. And this dotted line is the mean minus 2 times the standard deviation. Or I could take this dotted line and subtract the standard deviation from that. And between these two dotted lines, I would expect to find about 95% of the data. Virtually all of the data will fall within 3 standard deviations of the mean, or actually it's about 99.7%. So we're going to look at this problem with Eddie's Burgers. They recorded the number of chili burgers sold each day for the past 365 days. And the question is, do the data seem to come from a bell-shaped population? So in order to figure this out, it's a little bit of a process. What we need to do is find the values of these dotted lines, the ranges, using the mean and the standard deviation, which I've already calculated using Minitab. And then we need to see if 68% of the data, or about 68% of the data, fall between those two lines. So what we're going to do is start by calculating. So I already found my mean and standard deviation in Minitab. So you should be familiar with how to do that by now. And so I'm going to go back to here. What I need to do is calculate the mean plus the standard deviation and the mean minus the standard deviation. I'm going to round the decimals here to tenths just to make the numbers go a little bit faster. So mean plus standard deviation is 15.1 plus 3.1, which is 18.2. And the mean minus the standard deviation is 15.1 minus 3.1, which is 12. So what this tells me is that about 68% of the values should be between 12 and 18.2. So if I go back to my data set, now there's 365 values in this data set. So I could go through and count which ones are between 12 and 18.2 and figure it out that way. Like 14 is between 12 and 18.2. 11 is not between those two numbers. That's going to take me a really long time, so I'm going to make it easier on myself, and I'm going to create a tally chart or a frequency chart to show me how many of each number there are. So go to Tables and tally individual variables. And I want to tally the chili burgers sold. So this tells me how many times each number appears in the data set. So I want to find how many times numbers between 12 and 18.2 appear. So what I would do is I would add 31 plus 39 plus 34 plus 47 plus 38 plus 43 plus 31. And if I add all those numbers, what I should get is 263. And then I divide that by the total number of numbers there are, which is 365. And if I do that, I get about 72%. Now, 72% is not exactly 68%, but it's pretty close. If it's within 5%, I would say that that's probably close enough. So I would say this is close to 68%. So between one standard deviation of the mean checks out. Now I need to repeat this process for between two standard deviations, within two standard deviations of the mean, and within 3 standard deviations of the mean. So I'm going to calculate 15.1 plus 2 times 3.1, and that's going to be 21.3, and 15.1 minus 2 times 3.1, and that's 8.9. So this is telling me that about 95% of the data should be between 8.9 and 21.3. So I go back to my data set. Now for this one, it's easiest to calculate the ones that are outside the data set and subtract from 365. So this wouldn't count 7 and 8, which adds to 6 total days. 9 would be between 8.9 and 21.3. So that gives us 6 on that end. On the upper end, we're looking for values greater than 21.3. So 22 and 24. So 6 plus 5 gives us a total of 11. And 365 minus 11 would be 354. And then I do 354 divided by 365. And if I do that on a calculator, I would get about 97%. Now, it's not exactly 95%, but close enough. So that one checks out. And lastly, we need to test 3 standard deviations of the mean. So 15.1 plus 3 times 3.1, which equals 24.4, and 15.1 minus 3 times 3.1, that equals 5.8. So about all of the data, virtually all of the data, 100% of the data should be between 5.8 and 24.4. And if I go back to my data set one last time and look at my tally chart, I see that there's nothing less than 7, so nothing less than 5.8, and nothing greater than 24. So nothing will be greater than 24.4. So the 100 value also checks out. So our values for within 1 standard deviation, 2 standard deviations, and 3 standard deviations all were fairly close to the percentages that we expect. And therefore, we can conclude that in order to answer my question, do the data seem to come from a bell-shaped population? The answer is yes. The data seem bell-shaped. So it's one of the longer problems that we're going to see in this course, but basically it's just a matter of calculating those ranges and then using the data set to figure out if the percentages in the data set matches 68%, 95%, and 100%.